Good day, Professor. We are Team 7 and we're here to present on the Smart Street Light project that we've done. So, just a brief overview of our project. We have a problem statement, which is the current street lighting design and implementation in Singapore face some reliability issues caused due to some inadequate maintenance and fixed illumination schedules. These issues could actually cause safety concerns, particularly during nighttime and adverse weather conditions, where malfunctioning lights may fail to activate when needed. The lack of automated fault detection emphasizes these problems, leading to a prolonged downtimes and increased energy wastage. So currently, the market solution to monitor light levels for ensuring the light actually dims and on as needed, they are currently using light-dependent resistors. And for monitoring population, like the density around the area, to ensure that we can have adaptive lighting, like for example, if there's people nearby, but it's normally dark, so we'll light it up brighter. Or if there's no one using it, we can actually turn it off to ensure that we don't just keep it on throughout the night just because it's dark. So we ensure that this is what they have now, but we want to implement this into our solution. So to achieve this, we actually use several communication protocols and technologies. For our people sensing, we're using Bluetooth to check for people instead of using a microwave sensor, because it's at least actually significantly more cost efficient. As for communication between modules, due to the long-range nature of streetlights being maybe more than 15 or even 20 meters apart, and making sure that they can communicate through this distance, we are actually using LoRa, and we actually have a few implementations of LoRa with this network. And also we are utilizing sensors such as lux sensor to see if there's light in the area or not. So for adaptive dimming and lighting. So here's actually our prototype. So this is our network. So we actually have LoRa nodes and we have the light sensor. So the LoRa nodes is actually connected to the light sensor, and the LoRa node is actually connected to the M5 stick via UART, and the light sensor is connected to the M5 stick. So all of the data will be hosted on the M5 stick. Then you'll be sending to each other via the LoRa nodes, and then the LoRa nodes will then pass on, in the case for a mesh, pass the data to our master node, which will then send the data to the web server, or in the gateway sense, it will send all the data towards the gateway just via LoRa, and the gateway will send it up to the TTN. So this is our physical prototype. So it's just it's an implementation of what we have of the system itself, of the actual prototype. I can see the LoRa and the M5 sticks being hoisted up, and this is our dashboard to actually see what we have, to monitor the lights, and it's like scalable. We want to make it more, but some of them are dummy data but this is what we have currently. So for communication protocols between modules on the same lamppost, we actually use UART as mentioned just now, and the communication format that we're using is actually JSON, because it allows us as programmers to actually easily debug, even though it might cost a little bit more overhead, but it allows us to standardize the data throughout. So from to your TTN, you can do some passing, because the TTN language is JavaScript, so you can pass the thing through and send to our React backend. Then our React backend will then talk to our React front end via WebSockets. So all this is do JSON passing. So for future work, what we want to implement, but unfortunately we do not actually have the time, is actually one important thing. Even though IoT security is very important, so any packets you're sending, make sure there's some sort of encryption, base64, even a simple encryption, Caesar cipher. So that's what we were thinking of doing, but didn't want to do. And also, not just that, we want to ensure there's a decentralized architecture and fault tolerance, because we learned the concept of decentralization on your cloud network. So having that decentralization ensures that there's no single point of failure, and also some sort of redundancy. so that even if one thing fails, we have another thing to spin up. So maybe some that can be achieved via extra modules, or like modules in the same site to allow us to connect throughout every LoRa module. So we have, instead of one gateway, we have two for redundancy. Instead of one master node, we have two master nodes in this case. And thirdly, what I wanted to do also was ML on our data that we collected for predictive maintenance. So once we can actually get enough data, we can actually make sure that there's certain timings that this light may die, or this light may spoil. So either that, or maybe do throughout the seasons. For example, Singapore, when it gets hot, some equipment might malfunction due to extreme heat. So we maybe want to have some sort of ML to know these kind of things may or may not happen, and we can know before it actually spoils. We will give it some sort of maintenance so that it doesn't fail while in times of need, where there's a need for the light to be on but there isn't, and it will cost extra time and we need to speed up our process of repairing it lah. Yeah, so that's all from our team. Thank you so much, Professor.
So this will be our network architecture. So as you can see, it's similar to a TCP with addressing. So address 255 will be forwarded to everybody, and we have different packet codes for different purposes. So for example, your starting code is when the setup initializes, reply start code, packet code for normal packets, forwarding code for things that need to be forwarded, network catch-up, which we'll explain later, heartbeat out and heartbeat reply, which is to maintain the integrity of the network. So as you can see that the network is still on now. So as you can see, now it's setting up initialization message, and it's also forwarding the message wherever it needs to go up, because it's a 255. So any messages are forwarded back to here will be dropped because it's come from the original sender. As you can see here is a notification of the joining the network. So it's like an array of networks is joining, and you'll be updated for every node. Yeah. So as you can see, they are still in the startup process. They are still checking if there's any other nodes in the network. So it's just forwarding messages. After a while, it will nominate the master node. So as you can see, all of them have like a synchronized table of all the networks all the nodes in the network. So right now, after this, you need to know that the network is still in. So let's say if a node dies, or for example, our simulator will disconnect. So it's called a heartbeat check. The master node will send out heartbeat checks to all the other people in the network to sense if they're still in the network. So if they don't reply, they'll quote unquote drop them from the network. As you can see, it will start sending. So I simulated a disconnect via just disconnecting the LoRa. So you can see they're checking the network. It sends the lost heartbeat. So it just disconnects the So now this is the message structure that we'll send through the LoRa. Next will be our message constructors. So this will actually construct the message for each different packets, each different type of packets. So next will be the send message function, and you'll see it changes according to the packet code. So next will be my packet verification. So you can see it verifies based on origin duplication, auth, or destination failure. So it's not a destination, or it's not the thing. So next is when your actions, we receive different packets, you have different actions over here. For example, you need to forward and all that. Next will be network manipulation. So you either add, remove, or see if it's existing or not. And last is you check the constructor for bytes. So you need to change the message to bytes. And also, based on your packet codes, I have different packet codes for different actions for what the LoRa needs to do. So yeah.